Okay, hi. So I was asked to look at some of the 13, 15 section 6.8 problems. So that's what we have here. So here we have a function and it's a piecewise function and we're asked to graph it. Now the nice thing is that this is multiple choice, so that can help us. But sometimes it can be helpful to, kind of sketch a graph so we have an idea of what it should be and then uh, pick out which one of the choices you want from there. That can also help if you're graphing it by hand. For this one, though, I'm going to do it a different way. So different than I did in the first video, just to kind of change it up a little bit. And I'm going to instead look at using the choices and kind of eliminating or picking based on each one of these options that I have. So first of all, I'd like to look at, we have, this is broken up into three parts, okay? So I've got my first part, this is saying when x is less than or equal to -5, my output for my function is going to be x plus 3. Okay, so x is less than or equal to -5, my output is x plus 3. That's the first part. That's kind of its own function, and it's not looking at all x values. It's just for the ones where it's less than -5. At that point, I'm going to have a break in my graph. So then when I'm dealing with x values, when my input is between, strictly greater than -5, but strictly less than 6, my output is just a straight -1. So I don't have to really plug it into any function. It's just a straight -1. That works really nicely. And then my last example, or my last kind of, not example, my last part is for x values where our x values inputted are greater than or equal to 6. For that, we use the expression 1/2 x. Okay, so I've got these inputs, and then based on where x lies in these inputs, it tells me what output function I used. Okay, so we have to kind of determine where is x in that area. So one of the things that can be helpful is I can go ahead and, check these with just check certain points and see if they lie on my graph. I can also discuss, what's going to happen with each one of these. So I look at this first function and I see that that works for x values less than or equal to -5. So that's going to be on the left for my graph. And I see that it's going to be, when x is less than -5, it's going to be the graph of y equals x plus 3. So what do I know about y equals x plus 3? Well, first of all, it is a line with the slope of 1 and a y-intercept of 3. However, we're not going to get to that y-intercept value because we're, left of -5. So we don't even get to where x is equal to 0. But it can kind of give me an idea. I know slopes that have lines that have a slope of -1, they're going to lean to the right. And so when I see that, right away for B, when I go to left of -5, and if you can't see these, you can always just kind of zoom in. But when I look at and consider B, these are in multiples of 4. I see this, -5. I have a closed circle, so that fits, but my graph is leaning to the left. So if I checked like one of these values, I would see that it wouldn't satisfy, what I'm looking for this left one. For this first condition, this is an x plus 3 because this first part that I have, it has a slope of -1 because it's leaning to the left. We know that this has a slope of -1. So this isn't my y that I'm looking for. My x value is less than -5. So I can cross off B. I can definitively say, hey, B can't be it. So I'm going to do that. So I'm just going to eliminate B. It's not B. So let's keep moving on. For the same reasoning, then C is also going to be eliminated, right? If I look at that, again, for x values less than 5, it's leaning to the left, and that's not what we want. We want it leaning to the right because it's a line with positive slope. So it doesn't meet that criteria. Also, it doesn't contain that point -5. Okay, so we know that that first part is going to contain its boundary point, and this one doesn't. So for that reason, I know that it's not going to be C. So now we're already down to 2 choices. If any of you are older, you might be familiar with the show Who Wants to Be a Millionaire? And, there's that you can eliminate two, eliminates two of the wrong answers. We've already done that. We've already got, it's one of these two options. So we're already in good shape. That's helped us. Now let's consider, to narrow it down further, let's consider what else we have. Well, for x between -5 and 6, our output is a straight -1. So this means it's a constant on the open interval from -5 to 6. It's going to just be a flat line. But at -5 and at 6, we move to the previous functions. This is for the open interval. So we do want an open interval at -1. Now, when I look at A, I see that at negative, when we're at -5, it gives us this closed interval. So that's already, a sign that, hey, it's not going to be this, because we don't want a closed interval at 1. In fact, when x is -5, we're looking at the line, or with the graph, that first condition where it's x. We're dealing with a graph of x plus 3. So A doesn't fit that. If I look at D, I have an open interval from x equals -5 to x equals +6, where I have that output being just flat 1. Okay, and then we see that when we're dealing with x equaling -5, we have the graph that leans to the right of x plus 3. So that tells me, now we haven't even gotten to the third condition, but I can safely rule out A. Okay. So then that leaves us with D. Now I can check my last condition. What do I know for my last condition? It's a line with slope of 1/2, and it's specifically a positive 1/2. And so it's going to lean to the right. It's got a y-intercept of 0. Granted, that doesn't play a role because we're not dealing with x equaling 0. And that's going to go up 1 over 1. So it's going to lean to the right. That fits what I have for D. If I wanted to be, even better with my approximations, I can go ahead and plug in some table values. All right, so part of this problem that I'm skipping is the check with a graphing calculator. We'll do that in the next video. For now, this is just looking at another way of doing this problem without, with just exploring it algebraically.